Hello and welcome to the Delegate-based channel. In this tutorial, we are going to talk about C# events through the eyes of senior developer. You will not just learn what are the events, but you will also understand how senior developers in their practice using C# events. So let's get started. Here is our agenda. We have introduction section, a small section will talk about the events brief, and we have events from the senior developer perspective. This is going to be a huge practical section of our tutorial. Let's talk about events. Events allow a class or object to inform other classes or objects when something notable happens. We have publisher and subscriber mechanism in our events, so you can call publisher as a sender producer, or for subscriber you can use listener handler names. One publisher can have multiple or zero listeners, and if there are zero listeners, then the event will never be raised. In total, we have some type of notification system. Okay, you can think about it like you have a YouTube application, you have Instagram application. So you have some type of publisher, the author, and you have some type of subscribers, your subscribers. When you are publishing something, your subscribers should be notified about the published content. This is where actually we are using the event-based mechanism. The term event comes from this type of mechanism when you have some type of publisher and sender. This is our practical diagram. We are going to use iPublisher and iSubscriber interfaces for making things to be simple. I just removed all the signature elements like return type and the accepted arguments from this diagram, and we have only the methods like add subscriber, remove subscriber, and publish, etc. We have author and we have user in general. Author is our publisher and user is our subscriber. We are able to have direct communication between our author and user without a publisher and a subscriber type of interfaces. But in this case, we'll have tightly coupled system between our classes, and it brings a lot of complexity, like in the future maintainability, reusability, and extensibility perspective. For that reason, we are making things a little bit loosely coupled using iPublisher and iSubscriber. What is a loosely coupled mechanism? In loosely coupled mechanisms, you don't have direct knowledge between your author and user, but they actually can communicate with each other. So your author is able to communicate with user is able to communicate with author, but without knowing the exact implementation of the interfaces. That's how we are implementing loosely coupled systems. Okay. What is our learning path in this tutorial? We have classical implementation from bottom to top. We have classical iPublisher, iSubscriber interfaces. Actually, we are going to use observer design pattern in our practice, but don't worry, I will not talk about observer. It is complex elements, terms. Just understand that you have some type of notification system and you should notify your subscribers. That's actually all. We'll have a separate session related to observer design pattern. The classical implementation contains iPublisher, iSubscriber, strongly typed interface implementations, and then we have delegate-based modification for these implementations. So you will have delegate-based notification mechanism. Then we'll modify this delegate-based implementation to custom event-based. We'll use our subscriber delegate as an event element for the publisher, and then we'll apply Microsoft best recommendation stuff related to events, and we'll use event handler generic class for our publisher. That's what we are going to learn. Before diving into details, I want to mention that we have our GitHub repository for the tutorials. We have main branch here. Main branch just contains the description. There is nothing to do, but for the lessons, we have branching mechanism. For example, for the current event session, we have tutorial master C# events like senior, and you will find all the source codes we are talking here in this GitHub branch. Let's get started. In our Visual Studio, we have 5 projects in our Delegate-based solution. The only implementation-oriented class here is called, the project is called Custom Events in Practice Common. This is our common library, which we are going to use in all our console applications here. So we have one library and 4 console application. This is going to be our root abstract class domain entity. All our entities will inherit from domain entity. Actually, I tried to make things as simple as possible. For that reason, I haven't used the complex implementation. For now, we have only 3 properties. Every entity has their ID, created date, and updated date. And we have article, which we are going to use for all projects. Nothing will change for the project-based implementation, so I moved it to the common library. Our article inherits from domain entity. It has own additional properties like title, description, author ID is deleted and is published. And also our class consists not just from properties but also some type of behaviors. Actually, that is called the original domain models in programming. When you are using entity framework and you are implementing database driven applications, you only, in most cases, you only have classes that consist from properties. But in my case, we have a class consists not just from properties but also behaviors. This is actually called the original domain domain models. The models you're creating, they are without methods, and they are actually called dynamic models. In my case, I have a class consists from property and method. We have create, we have article update mechanism, draft, article delete, and also change article title and change article description. That's actually all what we have in our common library. The first project here is going to be our classical implementation. We should have our contracts like iPublisher and iSubscriber, and then implement author and the user and see how interface-based implementation looks like. So I'm going to add a new folder here, and then I will call it contracts. You can call it abstractions, contracts. It really doesn't matter for now. Let's add new item and let's call it iPublisher. This is going to be our interface. Okay, iPublisher interface. And iPublisher interface consists from several methods like add subscriber, and also we have remove subscriber, and we have with publish mechanism, we are publishing string message information. That's all what we have. I haven't added the subscriber because we don't have subscriber here. Let's just simply add our subscriber, iSubscriber. And for subscriber, we have subscribe, unsubscribe, and also notify mechanism. Okay. Subscribe, we'll use iPublisher, and let's create unsubscribe, and also we have notify method, which we will call in our publisher. And for the publisher, we have subscriber here, and also subscriber here. So we have bidirectional communication. Let's say here that using a publisher, we can publish, we can add our subscribers and publish. And also subscriber, from the subscriber perspective, it is easy for us to subscribe to the publisher and get notification. Okay, let's remove unused namespaces here. Do the same for the subscriber. That's how actually our interfaces looks like. So now it is time to go to our models here, and we will have our author. Let's add our author. So our author is actually going to be our record, and it is a domain entity. Just now, let's right click at project reference and add common. And now our author is going to be our domain entity. For the author, we have some type of additional properties like, let's say we have author property like name and description. Cool. Public string name get init and string. Okay. And also we have description here, and let's construct it. String name, string description. Cool. And let's initialize it. Name is name equal to name, and description equal to description. Cool. Now we have author information and we are constructing it using init. We are restricting that we should construct our author using our constructor. Cool. And what else we have? Of course, our author is going to be our publisher. So we should implement our interface here. For the publisher, we are able to have as many subscribers as we want. So we should store some type of list I subscribers. And this list, of course, can be nullable. So we have subscribers, yeah, and for the subscribers, let's make it to the nullable subscriber here. Let me just add underscore. Cool. Now we have a list of subscribers and it is possible for us to add subscribers. Subscribers, add given subscriber, and let's remove this subscriber. Remove subscriber. Okay. This is our nullable subscriber. So cool. And now it is time to publish. When we are adding subscribers, we are actually adding them to our private list, and we need to call our subscribers notify method for all subscribers. It means we have for each mechanism here, subscribers for each, it is going to be our subscriber. And for the subscriber, we are going to call our notify, and we need to have some type of string message, okay? And for the publisher, I added here just a string message, but I want to make it a little bit more meaningful. For that reason, I'm going to change this contract. Let's say it is going to be our article. We want to publish our article, okay? So it is going to be our article, and let's for the article do a create operation. Article, let's call it created article. And for the created article, I am going to call toString method here, and to make it the published message. Cool. Now we have published message and we are publishing this message. This is really easy. So you have a list of subscribers. Using these two methods, you're adding and removing subscribers. And also for the publish mechanism, we are publishing some type of article, okay? And first things first, we have draft article here. We are creating this article and we are making it to string to define the user, the article title, the other properties for article, and we are providing subscribe mechanism. Let's control D and let's format it. And now we have publish mechanism here. Cool. And for the publish method, we are doing for each, and we are calling subscribers notify method. Actually, subscriber notify method will handle all the notification mechanism, like if you want to store it in our database, or want to just publish it to the console, or depending from the notify implementation, we are able to store information anywhere we want. So cool. Now we have our author, and let's add our user here. User. Our user is also our domain entity, and it should implement iSubscriber. Cool. Let's implement iSubscriber, and it is going to be a record, and we have public string name for our user, and from the constructor, let's add string name, and let's define name. Cool. For the subscriber, we have subscribe. It means we are going to call at subscriber and provide this, because we are accepting publisher as an argument, and we are delegating at subscriber behavior here. And same is applicable for unsubscribe. So it is possible from the publisher perspective, accept subscriber to its list, but from the user perspective, it is also possible to subscribe to the publisher. And now we have remove subscriber this. Cool. And for the notify mechanism, I just want to console write line my message. This is not an ideal implementation. You can use, for example, you can instantiate your database and you can write the information to your database. But for making things simpler, we are just writing to the console. That's actually all how we are planning to implement our user for now. This is our iPublisher and iSubscriber implementation. So let's go to the program file. Okay, for the program file, I need to instantiate first my author. Okay, author. Let's add the author equal to the author, Frank, good author. Okay, now we are able to instantiate our user. It is going to be our first user. It is Michael, and we have another second user. They are actually our subscribers. Okay, let's call it publisher, first subscriber, and second subscriber. And we have another subscriber here, John. Cool. We are able to instantiate all author and user, and let's try to add subscriber first. And from the second perspective, I'm doing a reverse operation like subscribe to publisher. Actually, they both are doing the same operation. Publisher adds our first subscriber as it is subscriber, and second subscriber is going to subscribe to publisher. In general, we will have one publisher with two subscribers. Cool. And now it is time to publish some article. Okay, publish, and we have article here. Let's go and create this article. My article equal to new article, Kafka for mortals, description, detailed explanation of Apache Kafka, and author ID. We have author ID here, so it is going to be the publisher ID. Cool. And now it is time to publish this article. My article, that's all. Let's add console.readline. Let's run this application and see if everything is working. Cool. Now we have two information published for the we have the first subscriber, we have second subscriber, so we have two type of messages here. Cool. Now it is time to do some additional changes for the user implementation. Let's add some messages here. Message added for user ID equal to ID and message equal to the message. I just want to differentiate my users, and let's add console.writeLine, empty writeLine. Cool. Now let's go to program and run it. Now I have message added for user. This is our another ID, and we have two type of IDs for the first subscriber and second subscriber. It means everything is working. So what I'm going to do here, I'm just going to the publisher dot remove subscriber. Let's remove this subscriber, and let's do some modification to my article, and let's change it is title to just Apache Kafka. Okay, and it is going to be our my article, and I just want to publish this article again. So I have two subscribers here, one article. I am publishing this article. The two users will get notification. Then I'm removing one of them and trying to modify and publish article again. Now only first subscriber should get notification. Let's see console.writeLine, and let's remove this read line and put it to below, and let's run it. Cool. First we have two subscribers, and then we have only one subscriber because we automatically removed them. Now it is time to learn delegate-based implementation, but before diving into details, let's go to our slide and try to understand what we are going to do. In our delegate-based implementation, we have again publisher and subscriber. For the subscriber contract, we will not do any additional changes, so subscriber contract will stay the same. For the publisher perspective, we are going to modify our contract, and we are going to use subscriber delegate instead of subscriber interface. It is possible for you to do the same type of adaptation to your subscriber contract, but for making things really simple, I'm just going to change the publisher contract. Subscriber implementation will also be changed because it is delegating our publisher. So let's get started. It is really easy to adapt the delegation-based implementation. We already have the contract-based classical implementation. Let's copy the folder structure completely. Let's go to our subscriber. So as we said, our subscriber contract will not be changed. And for the publisher, we are going to remove subscriber interface communication here. From the subscriber perspective, we have publisher, but from my publisher perspective, we have delegates. So by the way, if you want to master delegates, if you want to learn delegates like a senior and apply them in your practice like a senior developer, we have really wonderful tutorial in our channel, so don't miss it. And if you like, please like and subscribe to our channel. So let's get started. We have public delegate void subscriber delegate, and it is signature. We have string message. Why? For subscriber, I have notify method here. Let's go for it. As you may see, we have the void as an return type, and we have string message as an argument. But in my case, I am replacing this notify with subscriber delegate. Instead of notify, you can provide any additional methods you want if it is appropriate for our delegates. So I'm going to change my subscriber to subscribe delegate here. What the only thing I'm missing here is my identifier, because when I add delegates to my collection, I don't have identifier to remove these delegates. For that reason, I'm going to not just provide the subscriber delegate in this case and notify method, but also my subscriber user ID. So for removing my subscriber, I will use only subscriber ID. That's actually all from the adaptation perspective. Let's see it in practice. So I'm going to implement my publisher here. Okay, let's remove add and remove subscriber methods here. And let's go for the newly generated ones. I'm not going to use list iSubscriber because I don't have any more iSubscriber interface communication with iPublisher, and I will not use a list. Instead, I have a GUID and subscriber delegate as a key value combination. For that reason, I am using here dictionary, and it is going to be GUID in our key and subscriber delegate in our value, and same initialization mechanism will be applied here. The only thing we need to do in add subscriber actually is going to add these subscriber and subscriber ID and subscriber. That's actually all. And from the remove perspective, it is also really easy to implement. So subscribers, remove subscriber ID. And for the publish method, we are going to do some for each operation here. So we have a collection of the delegates. So I'm using subscribers value to get the exact delegates we have. They are our subscriber delegates, subscriber delegate, and I'm going to call my subscriber delegate with published message. Cool. Now everything is ready. Now it is time. So actually you need to rename these namespaces. So let's do it. I'm just going to copy, go to author, and let's paste it here. Let's copy the whole namespace here and replace them. Go to user, apply namespaces changes, and for the publisher, iPublisher and iSubscriber also let's rename. Cool. Now everything should be okay. Now let's go to our first program CS implementation. Let's copy and let's adapt our changes. Now I have author and user. For the publisher, I have different signature here. It is going to be at subscriber with first subscriber dot ID and first subscribers notify method. Cool. And for the subscriber implementation, we also have some changes because we don't have a subscriber delegation to publisher. Now we have ID and notify methods here. And approximately the ID will be applied here. That's all. Now we are ready to run our application, but first let's try to remove it also after subscribing. Now we have one author, we have two users. I have one publisher. I have added first subscriber using add subscriber signature, and for the second subscriber we are using the via versa delegation mechanism, and we are through publisher subscribing. Now let's run. We should see three messages here. First two for two subscribers. Okay, let's right click, set as startup project and run it. Cool. Now we have two messages here for user. for this user and another user. Now we removed our first user. It means this one was removed. And now we have only one message after unsubscribe process, removing subscribe process. Cool. This is our delegate-based implementation. Actually, if you have one single method, one single signature without a state, you can use delegates instead of your interfaces actually. But interface, from the architectural perspective, interfaces are better than delegates. Cool. Now it is time to adapt our delegates to use events instead of delegates. Let's first go to our slide and try to understand what is event-based implementation. This is going to be a custom event-based implementation. First, we will adapt our subscriber delegate to be an event in our system, and then we'll replace it to the original Microsoft recommended event handler delegate. Event handler, event. Custom event-based implementation. So we have subscriber and publisher. For the subscriber, we're not going to change the signature as in our previous implementation. For the publisher, we're going to use subscribe delegate as an event type. And we are removing strongly contract-based implementation. Our publisher, we already did it. And the last thing is actually for the subscriber implementation, we need to do some minor changes. Okay, let's go to our Visual Studio, and I'm just going to copy the contract and models from the second project to the third project, okay? For the publisher, we have delegation mechanism. If you are adding events, you don't need add subscriber, remove subscriber type of contracts because our events already encapsulate add and remove type of event mechanism in itself. So it is really easy to work with events. Just remove these methods and type event subscriber delegate, and what we are doing, we are publishing some stuff, so it is going to be our own publish event. It means when we are publishing some article, we will check our publish list. If we have subscribers, we will notify them after publish done. So we have just event in our delegate type. What is actually event here? Event is a wrapper over our delegates. We are using delegates behind our events. It doesn't mean that it will be always choice for events to use delegates. Right now in C# we have only delegates for method encapsulation. For that reason, events use delegates. If we will have additional options rather than delegates, then event will be used this option also. But for now, we have delegate. For that reason, we are using delegates behind our events. Cool. Now, what should we do? We need to go to our implementation and do some changes. Let's just remove these methods and let's get our onPublish mechanism here, and instead of having this subscriber dictionary, we are removing all this dictionary stuff, and we are just calling onPublish, invoke publish message. You see, the event adaptation is really easy than adapting the strongly typed contracts. Why? Because in your system you already have event, and this event already encapsulates add and remove subscriber behavior. So there is no need from your interface perspective to implement add subscriber, remove subscriber. There is no need behind the scenes to store some type of private data structure to add your subscriber, to remove your subscriber. Everything already implemented in our own publish. Cool. Now let's copy from our second project, our program CS implementation, And let's go to the events and paste it here. Let's right click, set as startup project, and let's see. Right now, we don't have on add subscriber, we have only on publish. And for on publish, we are going to plus equal first subscriber notify. What does it mean? It means I have this type of delegate signature notify. I want my publish mechanism to get this notify method, and when we publish some event, just call this method. That's actually what we are doing here. And if you want to unsubscribe, you just need minus equal, and that's all. We are unsubscribing from our event. The only thing we are missing here actually is our subscriber implementation. Now we have on publish plus equal notify and minus equal notify. Cool. That's actually all what we need to implement in our system to be able to use events. That's actually all. You see, we don't have a complex contracts. We don't have any data structure to store the things. We are using events only when we have some operations happen, when we have some type of event, some type of news to notify our subscribers. And using events, you can easily do it. Of course, it is possible with delegates to do it also. We already did it. But in delegates version, we have a list of the subscribers. We need to store them. We need one by one for each and notify them. So delegate-based implementation is really complex. We are mostly using delegates only for method arguments. So from our previous delegate lesson, you already know that we are using delegate as an argument, as a callback mechanism. Mostly, if your system accepts a delegate, it means it is a mandatory. It should somehow be called. But in my case, we have event, and this event may have 0 or multiple subscribers. System will continue working without your event attaching, without your events actually. If I comment this code lines, system will work without any issue. But in your case, for the delegate, if you're using delegates, not our implementation, but just delegate instead of events, the logic of delegate means you should provide this information. You should provide a delegate somewhere. For example, your link queue method accepts a delegate. It means you should provide this delegate to work, to make your system properly work. But if you have events, you can just bypass them if you don't want to notify any part of your application. Well, that's actually all related to custom implementation. And now it is time to talk about Microsoft recommended event version. Recommended event-based implementation. In this case, we again have a subscriber will not change its signature, but the implementation will be changed. We have publisher, which will use not our subscriber delegate event, but event handler, generic event handler. And subscriber implementation will also be changed because it is delegating publisher. So let's go for it. Now I am just going to open another project here. Let's close all these ones and let's copy our contracts and models from certain to fourth project. And let's go to a publisher, and my publisher will not work with my custom delegates anymore. Let's just add reference to the common here. What we are going to do is actually to use event handler delegate. Event Handler Delegate is Microsoft's built-in delegates. If you have notification mechanism, it is better to use Event Handler rather than your custom implementation. So in my Event Handler, it is a generic type. What does it mean? It means in your system, if you have some type of argument, some type of data to provide to subscribers, you should implement Event Handlers event arcs argument. So we have, let's implement public class message event arc. This is going to be the article. We are going to store our article in a string format, and we are providing our subscribers some information about our article. So I need to implement my event arcs, and I have public string message. Let's just use like this for now. Okay, it doesn't matter for us, or you can use constructor. For now, I'm just using a required message, and it is going to be my message event arcs on publish. Cool. Now let's go for iSubscriber. We don't have any changes here. Let's go to our author. It is implementing a publisher. For that reason, we are changing this to event handler message event arcs on publish, and we are publishing a message here. When you invoke it, you should provide object sender and message event arcs. This is actually a template mechanism from the Microsoft. We have sender who is sending this information. This is going to be our author instance. So we are providing this in our case, and we have message event arcs. For the message event arcs, let's provide our published message. That's actually all. Let's do a little bit format stuff here, and then let's go to our user. Let's see if we have any changes here. So we on publish, we have event handler message event arcs rather than notify mechanism. Let's see what it should generate for us. So I'm just going class equal. Let's hit top. So in our signature, we should have object nullable sender with message event arcs. This is really easy to implement it using Lambda expressions if you don't want to create a separate method for them. So let's do it. And sender arcs, and in my case, I'm calling my notify with arcs.message. That's actually all. And let's do unsubscribe here. For unsubscribe, we have same type of behavior. So we are using sender arcs and notify arcs message. That's actually all for now. We are checking all this stuff from the publisher perspective. So for the user, it doesn't matter. We are just making it to be runnable rather than to properly handle all this stuff. Now it is time to copy our program CS implementation. Let's go to the fourth project, this Microsoft recommended ones. Now I have on publish here, and it has sender and event arcs mechanism. Let's type sender event arcs, just argument, and let's provide our arcs.message. Cool. Now let's do the same operation here to unsubscribe. Let's run it. It is going to be our third. Let's go and change it to fourth one. Right click, set as startup project, and run it. As you can see, we have 4 runnable method signature here. It is really important to understand because we are not providing the instances, but we are providing the actual methods here. So what's a problem in our case? Let's just format it. So you see, we have onPublish, and in onPublish, we are providing lambda mechanism here. We are not providing the exact address of our method. It is really important to understand. We are trying to unsubscribe, but this unsubscribe will not happen because we don't have proper subscribe and unsubscribe method signature, the valid address in this case. How to make things to be valid. It is actually possible to do it with multiple implementations, but for now I will add the same signature for my user to make the subscription process really easy. In my case, I'm going to my user and let's go for public with notify, and I will use object sender message event arcs, and I will delegate to my notify. Just I am using my internal notify with message event arcs dot message. That's all. Now it is time to switch. Let's close this and go to programs, yes, and let's add first subscriber dot notify. That's actually all. Let's do the same operation for unsubscribe here. And also let's go to our subscribe here. We need to change the signature. So it is going to be our notify with object sender event arc. So we have string message. We are providing the only notify method here. Let's use the save notify. System will automatically detect that only this notify signature will match to onPublish. That's all. Now in my case, system should be able to subscribe first subscriber and second subscriber, then unsubscribe the first subscriber. Let's run it. And that's all. Now we have first 2 messages for subscription process, and then we are unsubscribing and we have only 1 subscriber. Well, that's actually all. I hope I could explain events from the senior's perspective. And if you like my videos, please don't forget to subscribe and hit like button. See you in the next lesson.